The date is July 24th, 1915. The location is the Chicago River on the south bank in the industrial heart of the city, between Clark and LaSalle streets. A large passenger steamer named the Eastland sits tied to the wharf. This should be a routine excursion for a summer morning. Instead, it is the start of the deadliest maritime disaster in Great Lakes history. In the minutes that follow, hundreds will be crushed or drowned in plain sight. By the end of the day, the official death toll will stand at 844, a number the city will never quite set down. They will not die in a storm at sea miles from rescue. They will die 20 feet from the dry pavement of the city in plain sight. They will die while the ship is still alongside the dock. The Eastland is a long and narrow vessel. She is roughly 270 feet of steel packed into a river channel that barely accommodates her beam. She is known for her speed, but she is also known among sailors for being tender. She reacts sharply to weight shifts and requires careful handling. Today she is carrying a full load. She is licensed for 2,500 passengers, and this morning at least that many people are crowding onto the gangways. They are employees of the Western Electric Company heading for a company picnic across Lake Michigan to Michigan City, Indiana. The mood is festive and the decks are packed with families. But beneath the waterline, the engineering reality is critical. The ballast tanks are the only counterweight to the mass of humanity boarding the upper decks, and the margin for error is shrinking with every new passenger. The architecture of the Eastland has been compromised by good intentions. Following the loss of the Titanic 3 years earlier, Congress passed the Seamen's Act of 1915, often called the La Follette-Seamen's Act. The new rules pushed passenger lines to carry far more life-saving gear, lifeboats, rafts, and the heavy davits to swing them out. In some cases enough for roughly 3/4 of everyone aboard. On the Eastland, that added weight sat high, exactly where a tender ship could least afford it. This creates a condition known as top hamper. Top hamper is weight added to the superstructure above the center of gravity. It raises the center of mass and reduces the ship's ability to recover from a roll. The ship has also received several tons of concrete in deck areas to replace rotting wood. Tons of new material are pressing down from above while the hull fights to remain upright in the water. The ship is top-heavy and unstable before the lines are even cast off. The time is just after 6:40 in the morning. The crowd moves to the upper decks to wave at passing vessels and watch the river traffic. The center of gravity rises further. The ship lists slightly, first one way, then the other, as the weight shifts on board. The crew attempts to correct the trim by adjusting the ballast tanks. Water is admitted, but the response is sluggish. The list persists. It is not violent yet. It is a slow lean. The passengers laugh and joke about the angle. They do not understand that the vessel has consumed its safety margin. The physics of the hull are entering a terminal phase where the righting energy of the ship drops to zero. At 7:28 a.m., the ship commits, no longer wavering, only falling. The list deepens past the critical angle of 45 degrees. Furniture begins to slide across the decks. The laughter stops. A piano skids hard to port, nearly crushing people in its path. The crowd instinctively scrambles to the high side, but it is too late. The river water laps over the main deck ports. The vessel is no longer floating on its hull, it is rotating on its bilge. Some lines have already been cast off for departure, but the ship is still held alongside. A line parts under the strain. The Eastland does not sink. She rolls. Within a couple of minutes, the ship rotates 90 degrees onto her port side. The starboard side rises into the air like a steel wall. The port side smashes into the river bottom. The river is shallow here, only 20 feet, and it will not take her under. The hull does not submerge completely. It lies half out of the water like a beached whale. But for those inside the lower decks, the depth does not matter. They are thrown against the port bulkheads and instantly buried under tons of water and debris. The staircase becomes a ceiling. The door becomes a trap. The surface of the Chicago River is immediately a chaotic mass of wreckage and struggling swimmers. But the true horror is silent. Hundreds of passengers are trapped alive in the air pockets inside the overturned hull. They are dry, but they are sealed in darkness. The water's rising slowly inside the compartments. The city of Chicago stands on the bridge just feet away watching the disaster unfold. The question is no longer about navigation or stability. The question is how to break into a steel fortress before the air is gone. The stability of a ship is often misunderstood as a fixed quality. It is assumed that a vessel either is stable or it is not. In reality, stability is a dynamic curve that changes with every inch of roll. The Eastland did not capsize because of a single error. It capsized because it fell into a specific geometric trap where the forces designed to save the ship turned against it. The list to port was not just a warning, it was the physical manifestation of a mathematical collapse. And the reason comes down to two invisible points inside the hull. The first is the center of gravity, which pushes down. The second is the center of buoyancy, which pushes up. The vertical distance between these 2 points is called the metacentric height, or GM. This measurement dictates the ship's personality in the water. A large positive GM creates a stiff ship that snaps back quickly from a roll. A small GM does the opposite, the same tenderness her crews already knew by feel. And this morning, that number is collapsing. On this morning, the metacentric height had collapsed to mere inches, in some accounts about 4 inches. Concrete and extra life-saving gear had pushed the center of gravity up. Top hamper measured in inches. As the passengers boarded, they were not just adding weight. They were adding weight at the highest possible point of the lever. The result was a ship with almost no righting margin left. It was close to neutral, ready to settle at whatever angle wind or current might dictate. A near-neutral ship does not necessarily capsize on its own, but the moment you introduce moving water inside the hull, neutrality becomes a knife edge. The crew tried to fight the list by shifting ballast, admitting river water low in the ship, but in partially filled spaces that correction can turn into an amplifier. Sailors have a name for it, the free surface effect. When a tank is completely full, the water inside acts like a solid block of weight. It is stable. But when a tank is only partly full, the water is free to slosh from side to side. As the Eastland leaned, any water that could move would chase the low side. That shift of weight would deepen the list, and the deepening list would pull more water across. It is a feedback loop that can erase stability faster than any crew can react. The mechanism behind that roll is brutally simple, and it happens fast. As the ship passed the critical angle, the center of gravity moved horizontally outside the center of buoyancy. At this moment, the ship was no longer a floating vessel trying to stay upright. It was a falling object. The hull rotated around its center of flotation. The starboard side lifted out of the water not because it was light, but because the port side was being driven down by the massive leverage of the shifted water and the passenger load. The final resting position is not an accident. It is the new point of equilibrium. The ship is now perfectly stable on its side. The metacentric height has reset to a stable configuration relative to the river bottom. The hull is not sinking further because the beam of the ship is wider than the depth of the river. The port side is resting flat on the mud 20 feet down. The starboard side is horizontal in the air. The trap is locked. The physics have resolved themselves into a stable state of disaster. The problem is now structural. The passengers are no longer on a deck. They are standing on bulkheads or trapped in the underwater void between the two steel sides of the hull. The geometry that capsized the ship now holds it firmly in place, making escape nearly impossible. The scene on the river is a paradox. The ship is stable. The sun is shining. The water is calm. Yet hundreds are dead or dying within arm's reach of the dock. The crisis has shifted from a stability failure to a salvage emergency of the most brutal kind. The primary objective is not to raise the ship. It is to extract the human cargo from the interior. The institutional response is paralyzed by the scale of the trap. The hull is intact. The starboard plates are facing the sky, effectively sealing the interior from above. The survivors trapped in the air pockets are screaming for help, and their voices are audible through the steel plating. The standard procedure for a wreck involves surveys and permits, but the timeline for oxygen is measured in minutes. The decision that follows is not made by a committee. It is made by welders and local laborers who arrive with cutting torches. They arrive with cutting torches, shipyard tools pressed into rescue, and the only key to the lock. The workers climb onto the exposed starboard hull. They do not have blueprints. They kneel on the slippery steel and start burning openings into the plating. This action provokes a confrontation that defines the chaos of the morning. The captain of the Eastland, Harry Pedersen, is standing on the hull. He is dry, among those who did not even get their feet wet in the rollover. When he sees the torch crews cutting into the plating of his ship, he protests. He argues that they are damaging the company's property and weakening the hull. It is a moment of bureaucratic insanity. The rescuers ignore him. They keep cutting. They kick loose plates into the void and drop ropes down into the darkness. They pull the living out through smoke and steam. Inside the hull, the environment is hostile. The water is oily and filled with debris. The orientation of the world has rotated 90 degrees. Floors are walls, walls are ceilings. Divers and rescue men enter the submerged spaces through openings and cargo ports, working in near-zero visibility. They move slowly, searching by touch, through twisted railings and smashed partitions in the drowned staterooms. The psychological toll is immediate. The divers are retrieving bodies from water so shallow it should not be a grave, but the density of the victims is overwhelming. They pass the bodies out through the holes cut in the hull. The wharf becomes a morgue. The 2nd Regiment Armory is converted into a temporary morgue. The count rises hour by hour. It passes 500, then 600. When the counting finally stops, it stops at 844, 22 entire families erased. The rescue phase ends not when the ship is clear, but when the silence returns. The holes in the hull remain as permanent scars of the extraction. The oxyacetylene torches are extinguished. The surviving passengers are gone. The dead are removed. What remains is a massive steel obstacle blocking the Chicago River. Then the screams fade, and the river becomes a worksite. The city demands that the eyesore be removed, but the physics of the river have not changed. The ship is still heavy. It is still unstable. And now it has massive holes cut in its structural plating. The salvage engineers from the Great Lakes Towing Company arrive to survey the carcass. They are looking at a hull that has failed in every possible way. They must now do the impossible. Make it stand up. The risk now is that the ship will slide. The Eastland is not firmly anchored to the riverbed. It is resting on its side on a slope of soft clay. If the salvage team applies force in the wrong direction, the hull could slip deeper into the channel and block the entire river traffic of Chicago. The Great Lakes Towing Company takes control of the site. Their mandate is clear: right the ship and float it out. The problem is the mud. The port side of the vessel has been pressed into the river bottom by the weight of the capsize. This creates a powerful suction effect. The mud acts like a seal gripping the steel plates. To rotate the ship upright, the engineers must first break this seal without tearing the hull apart. They cannot simply lift the ship vertically. The combined weight of the vessel and the water inside it is far beyond the capacity of any crane on the lakes. They must use the river itself to do the work. The plan relies on a combination of buoyancy, brute force, and careful control. The first step is to prepare the hull. The holes cut by the rescuers must be patched. Portholes and openings on the submerged side must be sealed by divers. Then the engineers bring in pumps to dewater compartments and lighten the wreck. But lightening alone is not enough. They need controlled rotation, so they rig heavy cables and bring in cranes and lifting gear on scows and barges. Divers work in the mud to fasten hooks and slings to the submerged port side. 2 cranes work from the tug Favorite, and others take the strain from large scows. The river is narrow, the clearances are brutal, and every inch of movement is a risk, not just of damaging the hull, but of letting the wreck slide and choke the channel. To understand how a ship is raised from the dead, one must look at the mechanics of a simple barrel. If a heavy barrel is lying on its side, you do not try to lift it straight up. You rotate it under control, using leverage and the ground as a pivot. That is the heart of writing work. And on August 14, 1915, that logic is brought to bear on thousands of tons of steel lying on its side in the Chicago River. Buoyancy helps, but it will not roll a ship upright in a confined river. What the engineers need is a righting moment, controlled, relentless, and breakable. Cranes and winches take the strain, cables tighten, hooks and slings bite into steel. For a long time, nothing happens. The mud holds the hull fast. Then the suction breaks. The port bilge lifts free. The ship begins to roll. It is a slow and heavy movement, fought by water shifting inside the wreck and won by steady mechanical force. This is the most dangerous phase of the salvage. As the ship approaches vertical, gravity wants to finish the job all at once. The engineers have to manage the momentum, easing one line and checking another to keep the hull from slamming over. At last the ship settles onto an even keel. The Eastland is upright again. It sits low in the water, but it is floating. Pumps are driven harder to drain what remains inside. The water that pours back into the river is dark and foul. It carries the debris of the disaster. The turnaround time is technically astonishing. The ship capsized on July 24th. It is upright and refloated on August 14th. In about 3 weeks, the engineers have forced the wreck back into the shape of a ship. The Eastland is towed away from the wharf to a shipyard for inspection. But the technical victory is overshadowed by the atmosphere of the vessel. The Eastland is no longer just a steamer. It is a pourrieux. No passenger will ever pay to board this ship again. The name itself is toxic. The owners want to sell it, but the market for a ship that killed 800 people is non-existent in the passenger trade. The hull is structurally perfect, the engines are intact, the steel is good, but the identity of the ship is broken. The salvage team has saved the hardware, but they cannot save the ghost. The ship needs a new purpose, one that does not require public trust. It needs a buyer who deals in risk and violence. 32 years. That is the duration of the ship's life after the disaster. Logic suggests that a vessel responsible for the death of 844 people would be immediately scrapped out of respect or superstition. But maritime economics are colder than sentiment. The hull of the Eastland was only 12 years old. The engines were in excellent condition. To the men who righted her, she was not a tomb. She was a capital asset that had simply suffered a stability failure. The United States Navy agreed with that cold arithmetic. 2 years later, in late 1917, the Navy acquired the hull and stripped it of its public identity. In February of 1918, the old name was replaced. She became the USS Wilmette. The refit was aggressive. The lethal top hamper that had doomed the excursion passengers was cut down. Weight high on the ship was removed and the profile reshaped for naval training duty. The dangerously elegant lines of the passenger steamer were replaced by the gray utilitarian silhouette of a warship. For the next decades, the Wilmette served as a training vessel on the Great Lakes. Commissioned late in World War I, she did not live through the war from the beginning, and the fighting ended before she ever saw combat. But she remained in service through the years that followed, and through World War II, turning the old excursion decks into a factory line for seamanship. Thousands of naval recruits learned to march and handle lines on the very same decks where the Western Electric employees had perished. It is a grim irony that the ship became a school for stability and discipline. Rebuilt, cut down, and properly ballasted, she did not repeat the role that made her infamous. The ship became a familiar sight on the Chicago waterfront, but its history traveled with it in silence. To the casual observer, she was just another naval auxiliary. To the families of the dead, she was a constant steel reminder of the negligence that had destroyed their lives. The river water that lapped against her hull was the same water that had filled the lungs of the victims. The ship sailed on, completely indifferent to the tragedy of her origin. The end finally came in the aftermath of war. In late 1946, the USS Wilmette was sold for scrap. In 1947, the cutting was completed. She was towed to a yard in Chicago not far from the site of the capsizing. There were no cameras and no crowds. The torch that once cut openings for the living now cuts the ship down for scrap. The steel was melted down and recycled into the booming post-war economy. The legacy of the Eastland is not in the metal that was recovered, but in the questions that were sharpened in her wake. The disaster forced investigators, regulators, and ship owners to look harder at stability, not as a comforting calculation on paper, but as a brutal limit in the real world. It proved that good intentions like loading more life-saving gear high on a tender hull can carry lethal consequences when they ignore the physics of righting. It taught the industry that stability is not just a theoretical number on a blueprint, but a hard geometric limit that cannot be bargained with. Today, the section of the Chicago River between Clark and LaSalle Streets is quiet. The wharf is still there. The buildings have changed, but the river is still shallow and unforgiving. The physics of buoyancy and gravity remain absolute. The Eastland is gone, but the lesson remains. A ship is a machine that fights a constant war against the water. If the math is wrong, the water always wins. The salvage engineers proved they could beat the river and haul the wreck back into daylight, but they could never wash the name clean. The ship survived the disaster, but it never escaped it.